Hi, Andrew Dowdy here. The title of this presentation is Lidar and Archeoastronomy in the Lower Mississippi Valley. This is a somewhat pretentious title as I am neither an archaeologist nor an astronomer, but I have used Lidar quite a bit to look at images in this part of the country. Lidar, as many of you know, uses lasers to create high-resolution digital elevation models. The key to Lidar is that by manipulating the data, it can essentially see through forest canopy. And it can also pick up very subtle features not recognizable on the ground. It's led to significant archaeological discoveries in Central America and in the Amazon. LIDAR across most of the United States is available on the U.S. Geological Survey's national map. I've put a link to it here. The map has various tools for visualizing the ground surface. Archeoastronomy, the general definition, is how people in the past understood celestial phenomena and what role those phenomena played in their cultures. The specific questions I'm looking at here are: do Indian mounds in the lower Mississippi Valley share common alignments that are indicative of celestial phenomena? Let's take a look at LIDAR imagery of mounds. The example I'm using here are the Jordan mounds. They're in Morehouse Parish, northeast Louisiana. The image you see here is from an 1848 publication by the Smithsonian, Squire and Davis. It shows actually a sketch map of this mound cluster. If you look at a satellite image today, this is what you would see. The mound cluster is in a cluster of trees surrounded by flat, plowed agricultural land. So you can't make out much. However, if you look at a LIDAR layer that's designated hillshade stretched, you can clearly see the 7 mounds in this group. I found this to be very interesting, very revealing. One of the other things I discovered after looking at a few mounds is there seem to be some similarities among mound clusters. In this example, the Jordan mounds on the right seem to be somewhat similar to the Watson Brake mounds, another mound cluster on the left. They're only about 30 miles apart, but Watson Brake dates to perhaps 3500 BC and maybe 5,000 years older than the Jordan mounds. Nevertheless, as I was looking at them, I noticed starting with this elongated mound on the northwest side of both clusters seemed to have a similar alignment. And then there were several other alignments of mounds that also appeared to be similar. This led me to question whether or not we could identify common alignments among other mound groups in this area. So before we get too far in that, we need to understand what we're talking about. There's several challenges. The first is trying to figure out which alignments might be significant. So in theory, you might have an observer standing on a mound A, sighting across mound B and looking at a phenomena on the horizon. In this case, perhaps the rising of a star on the horizon. And we would normally characterize this with an azimuth. That's the angle measured from north, and in this case it would be a rising azimuth of 57 degrees. However, there's nothing to say that the observer wasn't standing on mound B, sighting back across mound A. And actually, the azimuth that you'd be measuring would be the setting azimuth at 237 degrees. So in reality, I have to define any alignment using both angles. Also, another challenge is the number of alignments rises exponentially with the number of mounds. Another challenge, of course, is the precision of measurements. I mean, mounds are basically piles of dirt. How precise can you be in sighting from one mound of dirt to another? I would say, based on my observations, I'd say generally I feel pretty comfortable within 1 to 2 degrees. If we were in a mountainous area, we'd also have to take into effect horizon effects. Undulations on the horizon could affect alignments. In this area, we're in a very level floodplain, and those effects are minimal. There are also latitude effects. We have about 2.5 degrees of latitude variation across this group, which could result in an azimuth variation of, say, a fraction of a degree. And finally, there's a question of precession. Star declinations can change over millennia. So if we're looking at really old mound groups, the stars could be slightly different than where they are now. So the area of investigation, as shown on this map, is northwestern Mississippi, northeastern Louisiana, and southern Arkansas. From a topographic standpoint, almost all these mound clusters lie on the floodplains of the Mississippi River, the delta country of the Mississippi, and there are several that lie up the floodplain of the Ouachita River in southern Arkansas. To the extent possible, I've used known names for some of these mound groups. In many cases, I found mounds that I couldn't identify with a name, and so I simply assigned a name arbitrarily to keep them straight. So let's take a look at some of these mound groups. These are the Grace Mounds in Issaquena County, Mississippi. Note the circled area is not a mound, that's a modern house site, but there are two mounds at Issaquena. If you draw an alignment between the two, they line up on 34 degrees or 214 degrees. This, it turns out, is a very common alignment. Same alignment you find at Boof River, Franklin Parish, Louisiana, 34 degrees, 214 degrees. Similarly, at Natchez Grand Village, Adams County, Mississippi, there were originally several more mounds. Today we still have 3, and they all line up on this 34-degree alignment. Wind Mounds to Shea County, Arkansas, similarly 34-degree alignment. At Tensas Bayou, Madison Parish, Louisiana, there's some fairly faint mound images here. One of them lines up on 34 degrees. There's also a much fainter mound down here. And so there's 2 other alignments, 3 mounds, 3 alignments. Bear Lake Mounds, Madison Parish, Louisiana. Here's a cluster with a number of mounds. 3 of them line up on the 34-degree alignment. But we have a number of others, and you can draw any number of alignments through these. And again, this illustrates the challenge of trying to figure out which alignments are significant. Lago Creek, Bradley County, Arkansas, there are 4 distinct mounds in here. 2 of them line up on the 34-degree alignment. There are other significant alignments in here, and I would say at Bradley, at Lago Creek, both of the solstice alignments are present. Boone Mounds, Calhoun County, Arkansas. Again, you can draw a 34-degree alignment. It also has some of the key north, south, east, west alignments, and then a number of others can be drawn through here. Pritchard Landing Mounds, Catahoula Parish, Louisiana. This is a fairly weak correlation, but I think you could draw a 34-degree alignment here. But again, these are big mounds, and there's several other alignments that appear to be significant. Ayden Mounds in Issaquena County, Mississippi. These are 2 small mounds, and they line up on a different alignment, 41 degrees to the northeast and 221 to the southwest. This is also another common alignment. We find it also at Georgia Bend Mounds in Sharkey County, Mississippi, 41-degree alignment. At Rift Branch, Ouachita County, Arkansas, a 41-degree alignment. In Arcola, Washington County, Mississippi, a 3-mound group, 2 of which line up on the 41-degree alignment. And there are 2 additional alignments. Transylvania Mounds, East Carroll Parish, Louisiana. Actually, 2 sets of mounds that line up on 41 degrees, as well as several other alignments. Mott Mounds, Franklin Parish, Louisiana. 2 of these mounds line up on the 41 degrees. There's also a possible weak correlation on the big mound. And then there are any number of additional alignments we could draw. Again, brings into question which of these alignments are significant. McDuffie Mounds, Catahoula Parish, Louisiana. To draw in a 41-degree alignment, there are also several additional alignments that show up. You could possibly come in with another solstice alignment here if you assume that little lump next to the river on the right-hand side was actually a mound. And then there's a pretty weak alignment here on the 80-degree, 260-degree alignment. As you can see, doesn't really line up on the center of this mound on the west side, west of the railroad track. The mound here to the southeast, interestingly, doesn't appear to line up, have a common alignment with any of the other mounds. A mound group which I've titled the Old Beer Joint Campground Mound Group, Union County, Arkansas. There's an alignment here at about 28 degrees, 208 degrees. Same alignment shows up here in Sharkey County, Mississippi. These are very faint bumps on the ground, which I think were mounds. Jakestown in Humphreys County, Mississippi, a two-mound group, has a different alignment. This is, in this case, the solstice alignment. There are several mounds that were here that have been destroyed, several additional mounds. Zumbro Mound, Sunflower County, Mississippi, another alignment, 51 degrees. And the Leland Mounds, Washington County, Mississippi, yet another alignment, 147 degrees. Balmoral, a three-mound group at Tensas Parish, Louisiana. We pick up three different alignments here. Winterville Mounds in Washington County, Mississippi. This is a famous mound group. The circled areas is not a mound. That's actually the visitor center. So you can measure a number of possible alignments here, some better than others. Again, if we go back to the Jordan Mounds in Morehouse Parish, Louisiana, try to figure out what possible alignments are here. You can come up with 6 alignments, all centered on the big mound on the west side, west central side of this mound group. But there's nothing to say that you can't line up some of these mounds on the east side, an additional 5. So possibly you could have 11 different alignments from this mound cluster. Again, back to Watson Brake, very old mound cluster in Washita Parish, Louisiana. And I think we can pick up possibly 6 different alignments here. So basically, I've looked at 37 mound clusters. Of those 37 clusters, I basically measured 133 observations, possible alignments, and they fell in 55 different alignments. However, if you discard the ones that only showed up once or twice, there are many fewer. In fact, the top 10 alignments account for 62 observations. About half of all the observations fall into these alignments. In this graph, basically, I've plotted the eastern azimuth, the rising azimuth in degrees versus the number of alignments. For the most popular one, with 11 alignments, was at 34 degrees. As we've seen, 41 degrees showed up in 8 places. We have 3 different alignments at 6 degrees, 18 degrees, and 28 degrees that occurred 6 times. We have 2 alignments that correspond to the solstices, one at about 61 degrees and one at 118 degrees. And then there are 4 alignments that show up 5 times at 80 degrees, 90 degrees, 120 degrees, and 154 degrees. So what do these things correlate to? And this is conjecture on my part. I think the 28 degree alignment may align with the rise of Deneb, that's in Cygnus, and that would be where Deneb would have been at about 1000 AD. The 34 degree alignment, the most popular, could be the rise of Capella around 800 or 900 AD. If so, there's a mirror alignment at 327. There's a few observations at 327 that could be the setting of Capella. The 41 degree alignment, I believe, corresponds to the rise of Vega. At 61 degrees, that could be the sunrise of the summer solstice. The flip side of that, at 241 degrees, would be the alignment of sunset at the winter solstice. And of course, the other solstice alignment, you could be looking at 118 degrees in the southeast, would be the sunrise of the winter solstice, or 298 degrees, which would be sunset of the summer solstice. In addition, there's an alignment at about 120 degrees. At one time I thought it might be a solstice alignment. I now believe it's probably a different star, possibly in this case the rising of Antares. At 80 degrees, there's an alignment which could be the rise of Betelgeuse and Orion. The alternative, it could be 260 degrees. You should be looking at the setting of Rigel. And then finally, At 100, there's an alignment at 129 degrees and one at 231. These are mirror alignments that could represent the rise and setting of Fomalhaut. So there's several alignments I can't correlate. There's a 6-degree alignment, and then there are two. The mirror alignments at 18 degrees and 341 degrees. It's unlikely that these are looking at celestial phenomena to the south, which they'd be very low in the sky. They're probably looking at circumpolar stars, not clear which ones, possibly something inside the Big Dipper. There's also an alignment here at 155 degrees, 335, that I can't quite explain. The distribution of these alignments, they appear to be pretty evenly scattered across the whole area. The solstices, there are actually very few, but they're scattered fairly evenly geographically. The same thing we see with the rise of Deneb, the rise or setting of Capella, the rise of Vega, Antares, a few spots. Betelgeuse, again, a few spots. Fomalhaut, about 9 locations, as I recall. So what are the conclusions? I would conclude that Lidar is a useful tool to image mounds. Certainly appears to be. It's certainly faster, less intrusive than ground surveys. You can also identify some very subtle features. I've concluded that Lidar shows common mound alignments in the lower Mississippi Valley. There are very few cardinal alignments, very few that line up northeast, south, and west, and to me, very surprisingly few solstice alignments, which seem to be the common alignments in many archaeological sites. I've also found, to me, there appear to be no obvious lunar standstill, major or minor standstill alignments, or alignments that would align with the maximum rising and setting of Venus. Of the alignments that are most popular here, they appear to be star alignments, which I've indicated. The significance of others is not really clear. I think from a research standpoint, obviously, a more rigorous analysis of this could be done, possibly broadening the geographic scope and maybe reaching some broader conclusions. From an astronomical standpoint, someone who's an astronomer could undoubtedly do a better analysis of possible celestial alignments. From an archaeology standpoint, I think the interesting question is, can these alignments be correlated with specific cultures? In other words, they don't appear to be concentrated geographically, but perhaps specific alignments are correlated with specific time frames. An interesting area. Finally, here's some general references. These are all books that folks may find of some interest. Anyway, thank you for your time.